Stand on a deck in open ocean. Every direction is identical. Now point at home. You can't. And in 3 weeks you are out of water. People crossed oceans like this for thousands of years. The trick is that this was never one problem. It was two. Which way am I facing? And where on earth am I? One of those got solved early. The other took centuries. Direction is the easy one, and you already know the answer. But here is what a compass never tells you. It tells you which way you point. It says nothing about where you are. So, position. Start with north and south. For that one, the sky simply hands you the answer. Measure how high a fixed star sits above the horizon. That angle is your latitude. That is genuinely the whole idea. You can do it with a flat piece of wood and a knotted string. Hold the string in your teeth. Line the wood up to the star and read which knot lands. You are doing careful astronomy on a wet, moving, tilting deck. In 1492, Columbus got his own latitude wrong by around 20 degrees. That is not a small slip. That is most of an ocean. And that was the easy half. East and west has no star to read. Known heading, known speed, known time. Multiply and mark the chart. And to know your speed, you threw a knotted rope off the back. Count how many knots run out while the sand runs through the glass, which is where the word knots comes from. It is literally the rope. The trouble is that every small error sits on top of the last one. 3 weeks in, careful guessing puts you somewhere inside a very large circle. Ships struck rocks they believed were 100 miles behind them. The answer, when it finally came, had nothing to do with looking at the sky. It was a clock. Noon happens when the sun is highest where you are standing. Nowhere else. So carry a clock that is still set to the time back home. When your sun hits noon, look at that clock. The gap is your longitude, which sounds simple. It was the hardest engineering problem of the age. Rolling, salt, damp, and swings in temperature. A pendulum is useless at sea. The man who solved it was a self-taught Yorkshire carpenter. He spent more than 30 years of his life on it. And here is the part almost everyone gets wrong. The famous Longitude Prize was never formally awarded. Not to him. Not to anyone. He was paid in grants, in pieces across 36 years. And the board that held it back were not simply being cruel. They were asking whether other clockmakers could build it too. His own design never went into normal naval production. Now for the part that is better than any of it. Navigators there crossed thousands of miles, carrying no instrument of any kind. Rising points of stars. The direction of the swell felt through the hull. Birds at dusk. And by the 20th century, that knowledge had very nearly disappeared. So in 1976, a canoe set out to prove it still worked. It needed a navigator who genuinely still knew how. The one they found was Micronesian. From a small atoll, 2,000 miles away, Polynesians relearned their own ocean from someone else's tradition. And those famous stick charts you have seen in museums, they never went to sea. They were studied on land and left on the beach. So, 2 problems and 2 completely different answers. The other took a clock that could survive the sea, and a carpenter who would not stop. There's a whole map of curious questions waiting at hello Curioo.com.